So I just spent the last 2 days trying to make aesthetic gradients work. And guess what? They barely even do. But I do have something. And now I'm going to show you how to do it in like 10 minutes. So that you can enjoy images that look like that, like that over there, and not have to wade through the sea of swill that I had to deal with for the past 2 days of nothing working at all. Okay, so here's how I'm going to break up this video. First, I'm going to talk about what aesthetic gradients are. Then I'm going to show you how to install everything that you need to start playing around with them locally. And then I'm going to show you how to get like good results and the tools that I use, which includes a script that I wrote to scrape images off the website. And then after that, I'm going to go go to sleep. That's the order of operations today. Okay, so aesthetic gradients, it's a paper. Yay! Right, it's got all these nice images. We love nice images, don't we? And the other thing about this paper that's really nice is that it's super short. It's like 3 pages, which is like, oh. What does this paper have in it? Well, here I'm just going to go over the really important bits that you need to know to use it properly. Later, I'll do another video like tomorrow about the inner workings and stuff. But for now, there's just one important thing you need to remember. So, you have your diffusion model, right? And this model takes in some Gaussian noise and it spits out the other end like some sort of nice image. Like this one, for instance. But that's not the whole picture, right? There's also like a prompt involved. Like in this case, portrait of a woman. And behind the scenes, what happens is that prompt gets converted into something called an embedding. And the embedding is fed into the model along with the noise, and there's like a whole bunch of back and forths that happen here. And eventually the model will spit out your image of a woman as opposed to any of the other millions of things that could be spat out instead. Now, the whole idea behind this paper of aesthetic gradients is that this bit here, the embedding, just based on these words, is not specific enough a lot of the time. So let's say, when we say portrait of a woman, we're sort of imagining like kind of a model, almost like a model in like an ad of some kind, who's very sort of airbrushed and like smiling, that kind of thing. And what we're getting out is an image like this, which is it's sort of like it's like not a photographic portrait, it's like a painted portrait. The person looks a bit gloomy, you know, all that kind of stuff. So how do we achieve our desired result? Well, one thing we could do is add more words to the prompt. And then therefore we change the embedding in that way, and then out comes something that looks a bit more like what we want. But the idea is that this is kind of hard a lot of the time. Like, we have this really specific thing in mind, and putting it into words, and also words the computer's going to understand and recognize, is like difficult. So the solution is that you grab a bunch of these images. Like, let's say, you know, purely hypothetically, that you would scrape 5,000 of these images off the internet. And you grab them all, and just like you created the embedding from the actual words of the prompt, you create another embedding from these images, and this is called the aesthetic embedding. So now we've sort of got these 2 different embeddings, both of which specify something about what we want. On the one hand, we've got this sort of look that we're looking for. On the other hand, we've got a physical description of what we're looking for. And we feed these both into the model, and as a result, our output, you know, rather than being only informed by this, it's informed by both of them, and then hopefully you get a better image, like the images that I ended up getting. Like this one that I ended up getting towards the end of this horrible 2 days. Okay, so that's how it works. You have your noise, you have your prompt, and then you also have this aesthetic embedding, and all of these 3 things go into the model, and these 2 things, the prompt embedding and the aesthetic embedding, they kind of like sort of battle for supremacy, and you can choose how much weight to put into each of them, and ultimately you can get out this nice image, hopefully. And the idea again is that some things that we want the model to make are difficult to express in words. That's basically it. This is like an alternative thing for expressing things in words. You can express it in images instead. And that's like cool, you know, right? Because like a picture tells 1,000 words. And hypothetically, let's say that I have watched Spirited Away and I saw that scene where there was like a train track in the water, and since then, that is the only thing that I can think of day and night, and I just want more of that. Please, 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 please. Like, if I ask a diffusion model, hey, give me the train track theme from Studio Ghibli, it'll have no clue. So instead, I can just feed the image into it and say, hey, give me this. Do this for me. This is the one. And then hopefully I'll actually get what I want. Really important. Super big important. Important, super big. Okay? You don't retrain the diffusion model. There is no major retraining happening on your model. It's not like Dream Booth, where you give the model like new images and new concepts that it has never seen before. This is all about telling the model which things that it already knows about to use. You're not teaching anything new, you're just expressing yourself more clearly with this aesthetic embedding. Okay? So if you were to give it heaps of images in your aesthetic embedding of like some celebrity the model doesn't know about, like Liz Truss, or I don't know, someone who just came up in like the last 3 days, that won't help. Because the image model doesn't know about that person. And so you'll be expressing something, that person's face, that it'll have no clue how to deal with. Great, that's all you need to know. That's all you need to know about the paper to be able to use this properly. Okay, cool. So, now the installation process. So again, I love doing things kind of from scratch. I'm going to assume that you have Python installed on your computer. I'm going to assume you have CUDA installed on your computer. Those are the two things that you're going to have installed on your computer. Okay, just assuming that baseline, we're going to install everything we need to start using aesthetic gradients. Now, as always, Automatic and the 180 other contributors on this Webui project are Speedy Gonzalez's, and they've already implemented it. So there's actually no complex installation required. You can just rely on them to handle all the backends. So we're just going to download the Webui. This time, I'm going to assume that you don't even have GitHub Desktop installed. So the first thing we're going to do is install GitHub Desktop. And this will allow us to pull down the repository in like a nice way. That will mean that whenever updates occur to the repository, we'll be able to access them really quickly. Okay, so the download finished. It's like 141 megabytes. Double click that mofo. Yeah, and this is what you should see. If you see this page, it's working. Now we're going to close this. Don't need that anymore. We're going to go to code, and you should see this option here. Open with GitHub Desktop. If you don't see the option, you may need to refresh your window or something, or close Chrome and open Chrome again. But you should see this. Open with GitHub Desktop. In my case, I'm going to hit this clone again button. In your case, just hit like the clone button. It might be a bit different for you. Okay, cool. So now we're on this page. We know that it's kind of worked. And you might be asking yourself, like, where is the code? Where has it gone to? Well, you can click this Show and Explorer button, and it'll bring up the code. So in my case, it's just this PC documents GitHub, and it's under this Webui folder. Okay, great, cool. That looks pretty good. Now, before we go any further, we have to do one thing, which is include the Stable Diffusion model in this project. Now, there are some links to the actual model itself. Yeah, so if you go to this dependencies thing, then you can go to the official download. That opens Hugging Face, which, by the way, hire me, please. And here you can download the model. By clicking one of these links, you might have to sign up yourself and, you know, agree to some certain things, but this is where you can find the model. I have actually downloaded this model myself. I keep it in the documents folder SD models. It's called model.ckpt. You can use 1.4 or 1.5. Any version of Stable Diffusion is fine. The only important thing is that you call it model.ckpt. No other name will work. And you go ahead and plonk that inside this folder where it says Webui models, Stable Diffusion, or this might be a longer name for you. It might not be Webui. Webui, it might be like Stable Diffusion, Webui, something like that. So, but the root folder, models, Stable Diffusion, and plonk it here next to this file that says please plonk it here, and make sure it's called model.ckbt. Okay, great. Back to the root, and now all we have to do is double-click this webui.bat. Okay, and now it'll install a bunch of things, and this process can be kind of long, so you might want to go and make a cup of tea or something. Okay, so everything's installed. No worries, that took like 30 minutes. And now we just have to go to this interface, so we go to localhost 7860, and we'll find the interface here. So, nice, Webui installed. Now, the next thing we have to do is install the aesthetic gradients extension. And the way that we do this is we go to the aesthetics gradients extension GitHub page, and we open with GitHub Desktop. And then the thing we have to do is we have to choose where to put this locally. And we have to put it inside the other Webui. So this is the Webui folder where we installed the Webui. Then we go to extensions. And just inside this extensions folder, we say select folder. And this will mean that the extension will be installed inside that folder. So now we just clone. Usually it's really bad practice, by the way, to put GitHub repositories inside other GitHub repositories. But in this case, we'll make an exception. So that was really quick. So if we go back into Webui, look at extensions, okay, the folder's now there. Okay, so now all we need to do now is click webui.bat and start it up again. And this time, now the extension's been installed, it'll load with the extension present. Okay, great, it's spun up again. Localhost 7860. Okay, and now we have this new panel relating to the aesthetic gradients. Okay, now because we want to go carefully and slowly with these sorts of things, what we're going to do first is use an aesthetic gradient embedding trained by someone else. So where do we find those? Well, they could be anywhere on the internet really, but I found a whole bunch of them at this link. What we're going to do is we're going to download 3 of these guys. We're going to go Azovsky Pit, Leon 7, and Leon 8. Okay, so again, you just open those in new tabs and then download, download, download. Okay, so now we've got all those 3 sitting in our downloads folder. I actually have them from before, so I'm going to use the older versions. And we cut those. Go back into the Webui, extensions, table diffusion gradients, aesthetic embeddings, and you chuck them here. So extensions, gradients, aesthetic embeddings. And they'll all have PT at the end of them. So we've added a bunch of embeddings. Now if we open up this folder again and we pick an embedding, at the moment it says none. There are no embeddings to choose from. But if we refresh this, now, great. The ones that we added are sitting there. So let's start off with the Leon, the SAC 8+. 8+ refers in this case to the user's rating of how aesthetic an image was. So the idea is that we can generate some images, and then if we use this embedding, it'll make them look a bit more aesthetically pleasing. Okay, so let's conduct a small test. We'll just generate an image, and then we'll compare the same image generated with an aesthetic embedding as well. So I'll create an image, a cat, that's our prompt, and we'll make sure that we set the seed to something particular so that both the generations will happen on the same seed. Lastly, we go to this section and we make sure the aesthetic embedding is set to none, which means that no embedding will be applied at all. Okay, prompt, seed, batch size of 1, okay, generate. Nice, and we've got our cat looking directly at the camera, all good. So now we go ahead and add the SAC 8+ aesthetic embedding, and we'll keep these settings as the default, that's all fine. So now we're generating exactly the same image, but it'll hopefully look a bit more aesthetically pleasing. Okay, and the result was identical. These are the 2 results. Now, is one cat more aesthetically pleasing than the other cat? Maybe? Like, this cat seems like maybe is a bit more of a Chad. I don't know. But, okay, let's just, probably we just need to add more strength. So, we're going to increase the aesthetic steps from 5 to 15 and see if we get any better results that way. Okay, so obviously this is a huge difference. It's actually turned the cat into a painting. although it's kept a lot of the cat's features. It still has kind of the same coloring. The green eye is still there, although that one was orange. But I feel like this has probably gone a bit too far. So let's go ahead and tone it down to like, let's say 9, and then generate again. Okay, and here we can kind of see the results. This was the original cat. This is the one with the aesthetic embedding applied. And now obviously this aesthetic embedding is kind of like a nice painting looking embedding of some kind. And it'll turn the images that you are creating, it'll make them look kind of artistic. I guess this is almost like a Mid-Journey Afire, kind of. It's sort of in that vein. Cool. Okay, so aesthetic embeddings, like, it looks like they kind of work. Let's do another experiment just to ground ourselves a little bit. Let's have a look at Aivazoksky. So this is a Russian man. And he's known for doing these kind of paintings that look like this, and he's known to be quite good. So the guy who wrote the paper trained this himself, this Aivazoksky embedding, on like 5 different images from Aivazoksky. So let's try a tree. Great, and we'll turn this off for now, and we'll generate our tree. Looks nice, looks like a tree. And now let's try Aivazoksky version of the tree. Okay, now again here you'll notice that not much of a change has occurred at all. The tree looks almost exactly the same as it did in the first run. So let's maybe up the number of steps to 18, see if we get some kind of result now. Ideally, this should end up looking a bit like one of Aivazoksky's paintings. So we're definitely seeing some kind of a change here. Does this look like an Aivazoksky painting? Not really. I don't think so. It's definitely made some kind of a difference though. So let's just go ahead and up the embedding to like 30. Okay, so now this is looking a bit more like Aivazoksky. Maybe there's a painting of a tree that we can compare it to. Yeah, so like, okay, that, I guess you can kind of see it's a bit similar. Just for the fun of it, let's just boost it up to like 45 and give it another crank. Okay, and here we have, again, the tree looks a bit nicer. We've now got a nice looking tree. Something you'll notice is that pretty much all the features of the original image are like gone. And that's actually sort of what you'd expect. Remember, now we're generating an image to fit these 2 embeddings, both the prompt and the new embedding you're giving it. So it's not like you're making a small alteration to the original image. You're actually asking the model to create a new image that has this negotiated weighting between these 2 embeddings. So don't expect the new images to look like the original images, unless you have the aesthetic steps down very low. Before we go on though, I want to kind of break this a little bit, because these aesthetic embeddings don't always work, and I want to prepare you for the circumstances where they don't work. So let's find something that Aivazoksky never would have touched. What's a subject he never would have touched? A hamburger. So first we'll set it to none, and then we'll just generate a hamburger, no aesthetic embedding at all, just a nice hamburger. Great. Looks like a hamburger. So now we'll go to Aivazoksky and generate. Now, I guess what you'd hope in this case is that you get a hamburger that looks like it's been painted by Aivazoksky, but what you end up with is a ship. Okay, so what's happened here is that because the aesthetic weight is so high, what ends up happening is the model pays way more attention to the aesthetic embedding and only a little bit of attention to the original prompt. And because there's sort of no overlap between the 2, like there's no hamburgers in Aivazoksky, it ends up just going with something random from the aesthetic embedding. So one thing we could possibly do is maybe try to reduce the steps like a lot. Let's go back down to 8 and then try again. But I don't think this will work though, right? And what we end up with is a hamburger that looks almost identical to the original hamburger. And it doesn't even look a little bit Aivazoksky-esque. And so I suppose, again, we're trying to get this negotiated, combined embedding. that represents the idea of what you actually want. And the model is having difficulty sort of meshing these two things. It's having a lot of trouble creating an embedding that is both a hamburger and also something that Abazonsky would have painted. You know, it's having trouble with that. Let's add some more steps. Or at least that's my theory. I don't actually know what's going on under the hood, but that's a pretty reasonable guess. So even at bloody 23 steps, you end up with just a different looking hamburger. This was the original, you know, there's no beef anymore. So maybe Abazonsky was like a vegan or something, I don't know. So let's boost it up to like 30 steps. And eventually we'll probably see this sharp shift where we end up with just something random that does look like it's been painted by Abazonsky. Okay, so now the burger looks a bit more artistic, doesn't really look Abazonsky style. What if we go up to 35, 38? Okay, this is definitely quite an artistic hamburger, but again, it doesn't really necessarily look Abazonsky style. Let's try 42. This is kind of fun. Okay, and then and then it just blew up. So we have this like hamburger progression, right? From this to this to this to this, and then we've just passed completely over to the embedding, and the embedding is all that we care about. So yeah, watch out for this kind of phenomenon. I find I get the best results where there's some overlap between my embedding and the prompt. Okay, but that's great. This is how to use other people's embeddings. We don't care about that. We don't care about other people. We want to make our own embeddings. That's what this whole exercise is about. Okay, luckily there's this new tab here. It says Create Aesthetic Embeddings. And all we have to do is choose a name. So what I'm going to do is, mine's going to be like a portrait-focused one. So I'll do portrait. And then we have to fill a directory with the images that our embedding is going to be trained from. And then we just show which directory that is, put that in here, and then just click create, and it'll take like a minute max. It's really fast. Okay, so where are we getting these images from, and how many of them are we going to need? Now, I've done a lot of experiments, and I'll show you the results at the end. For now, I'm going to get like 5,000 images, as many as I can, of really good artistic portraits of people. And the way that I'm going to get those images is I'm going to go to this website called ClipFront, which is a way of accessing a huge database of captioned images called Layon 5B. And I'm going to search it. I'm going to do the search like HD digital art portrait. And it'll give us a bunch of images that fit this that description. So we've got some HD digital art portraits. This is kind of exactly what I expected. The idea is that using these images, we'll create an embedding, and the embedding will tell the model, hey, you know, make this image look like a nice portrait. And that's sort of an idea that's a bit hard to express. Or maybe you'd have to use a lot of qualifiers and it wouldn't be quite as good. I don't know. Okay, so what we're also going to do is we're going to go ahead and put the aesthetic score up to 9. So this is like users have rated these images on how aesthetically pleasing they are. And so we're just going to grab the ones that are like 9. So in theory, these should look better. I guess these images should look better than the ones that we just had. I find that when you put the aesthetic score up, all you get is pictures of women. So be warned. Okay, great. So I've done my search. Now I'm going to do is download this file. And unfortunately, this doesn't actually download the images, which sucks. Instead, it downloads a big JSON file. It's just a special format of file, don't stress too much, which gives all the URLs of all the images that you can go down, download them manually yourself. I'm not going to do it manually. I've actually created a little script, which is linked in the description. You can download it yourself. And we're going to use that script to actually do the downloading. As you can see, it took that amount of time to actually download this file, but here's the file. clip subsets.json. I'm just opening up in VS Code, and this is what it looks like. It's just like a whole bunch of, it's a list of caption, URL, ID, similarity. And all we really want is the URL. Now I'm going to get the program that I wrote to download that, and I'm gonna start using that. So I'll just go, it's called clip download. It's like very, very rough and dirty. So again, we'll say open with GitHub desktop. And you'll have to choose a location to save it to, but it's called clip download, and then we'll show in Explorer. Okay, here it is. Now we'll just go to downloads, find that clip subset.json, and plonk it in here. Okay, that all looks pretty good. Now we'll open command prompt, and then go into that folder. So here that's documents, GitHub. What does it say there? Download images. Click download. Okay, nice. And then we install the requirements. So pip install requirements.txt. You have to go pip install r requirements.txt. And what this does is it just installs all the Python packages you need to run this code. There's only one Python package you need. It's called pill or pillow. It's for processing images. We just need to do one last thing, which is create a folder called HD, and that's where all the images are going to be saved to. So get back in our command prompt, and then we go python download.py. So as long as you have those things together, HD download.py clip subset.json, then it'll work. And so it's saying image successfully downloaded, and then some images it won't work because there's like 5,000 of them to download. But that's fine. And you can watch them being downloaded. You see in here HD, there are more and more images popping up, and they all look fine. Okay, so we're downloading. Now, I'm going to stop this process because I already did it earlier. And I already downloaded those 5,000 images. So now we're just going to use the images that I downloaded a while ago to actually create our embedding. They're under documents, portraits, and there's literally 5,000 of them. So that's cool. So now we have all our images in one directory. For you, it'll be that HD directory. Now all we need to do is tell the Webui where that directory is. So copy the path, get back into the Webui, go ahead, source directory. And the last thing you're going to want to do is chuck this batch size down to 128. The batch size should always be a power of 2, so it went down from 256 to 128, that's all good. And now we say create images embedding. We can see how this is progressing by going into the Webui batch file that's sitting there, the command prompt that's running the Webui, and it'll tell us how it's going. Okay, and now we've got this error, which is that it cannot identify this image file, 1170. So that probably means there's something wrong with that image file. Let's have a look. Yeah, so 1170, it looks like that particular file, it isn't a correct image file. Now, I've added some improvements to the script since I downloaded them the last time, and you shouldn't get any of these. But if they do, you just have to find the image and then delete it. Now, we'll just try exactly the same thing again. And watch our progress down here. Okay, so training's complete. We've got our embedding. And for you, it'll say like training complete up here in this section. It doesn't say that for me because this is actually the next day, because I was recording last night and I forgot to actually record. So I lost a whole bunch of footage. And I thought that was the time to go to sleep. One more thing before we go on. This batch size thing is important. If you keep it at the original batch size, what kept happening to me is that my computer, which only has 8 gigabytes of GPU RAM, ran out of memory all the time. So if you make the batch size half of what it was originally, that'll mean that you don't worry about running out of memory. It'll all be fine. Okay, now that our embedding has been created, we'll be able to see it alongside all these other embeddings here. So we give it a refresh. Okay, great. And there's this new portrait embedding. So ideally what this embedding does is it captures the concept of a very nice portrait of a human face that's attractive. And because we got it from that Leon place, and all the most aesthetic ones were portraits of women, basically it'll probably just be a female face. Okay, so now we're going to test if this embedding is any good. So first we'll generate an image without the embedding. And we'll of course set the seed to 999 so we can actually get the testing working correctly. Okay, and we have this not particularly stunning image of a lady. So that's actually kind of good news, right? Because the idea is that now if we add the embedding down here, portrait, and we generate exactly the same thing again, hopefully we'll get something that looks a bit better. Now it'll take a little bit longer to generate with the aesthetic embedding because you have to do some stuff first, but okay. And just looking at that, I'd say that we have a bit of success here. So this portrait definitely looks a lot nicer than this portrait in a lot of ways. This face is a lot more aesthetically pleasing, the lighting is a lot nicer, it's like a lot smoother. Okay, so the aesthetic embedding we trained on the 5,000 images, it looks like, you know, we probably did a good job there. Of course, you could also get a similarly nice image by adding a lot of different prompts. That'll be one other way of doing it. But the theory is that maybe this embedding we've made is going to be a lot more consistent. And rather than having to jiggle around with lots of different prompts like airbrushed, fancy eyes, you know, we can just use the embedding. 5,000 is a lot of images though. So we're going to do some more experiments here. I already generated a embedding with only 800 images as opposed to 5,000. So we're going to test that embedding against this new one. I've got them all stored here in this aesthetic embeddings folder. Cut this one. Webui extensions, aesthetic gradients, aesthetic embeddings, chuck it in. Yeah, so again, this is just 800 images from exactly the same subset. Refresh, PT 800. Okay, generate. And we'll see if this one's any better or worse. Now, this looks basically identical to me. So these are the two. They look really similar to me. Perhaps you could make an argument. You could make an argument that this one, like the nose is a bit nicer, right? This one, the nose is a bit fleshy. This looks like a proper nose. Maybe there are some other small things about the second one that are a bit nicer, but this is really an argument. There's so little difference. So that's nice. And I think we should go one further. I'm just gonna grab 20 from the same subset, train a new embedding, and we'll see if how they compare. Okay, so this is the portrait folder with the 5,000. I'm just gonna grab, how much is this? I'm just gonna grab 20 at random. Cut them. New folder. P20. Okay, cool. Generate a new embedding, and this is really fast. And create images embedding. We just have to make sure that it's down at 128. Okay, create images embedding. It says loading. We check the progress here. This little line will come up. It'll be like one iteration, all this nonsense. I don't know what's going on exactly. And okay, it finished already. So that finished in like 20 seconds or so. That was really quick. So text to image, refresh this, PT20, let's go. And again, this looks bloody identical, doesn't it? I'm really struggling to see any difference between these two. There's maybe like a little bit more shadow on that side of her nose. So this is the progression of the images. No embedding, 5,000, 800, 20. There's barely any difference between the three. So that should help us answer one important question, which is how many images do you need to train one of these embeddings? The answer is like 20. 20 is fine. 20 is enough. I have one more important thing to say about training aesthetic embeddings, and that's there are lots of things that you can't train an embedding for. Basically, the things that you can train an embedding for are really broad concepts. So a very good example of what you can train, as we saw just now, is well-made art. If you train it on images that are all very nice artistically, the embedding that you create will be able to tell the model to make something that's artistically nice in a broad sense. Other things like attractive facial features seem like an embedding you can do. But a particular artist's style, or like a particular kind of object, or a particular color, these are things that doesn't look like you can train embeddings on. So we saw, for instance, with that Russian painter, that you can get nice paintings of trees, but with other objects, it's pretty hit and miss. So get like 20 images, make sure that they correspond to a very broad concept, not like a narrow concept, and that should give you a good embedding. Is this any better than prompt crafting? I don't know. I think it might not be, really. I'll show you just briefly some of the failed experiments that I did. I trained a model in the style of Studio Ghibli by getting like 2,000 frames out of the movie Spirited Away. And these were the results. Trying to make a dog, Studio Ghibli style. As you can see, completely failed. I had a little bit more success with a woman standing in a field, but for the most part, you just ended up with these images that looked like photos, but a bit strange. The interesting thing was that all these women who ended up looking like they were photographed did turn into Japanese women when you applied the Studio Ghibli embedding. So I guess it's not always clear where the embedding is going to go. I trained one on 4 images of the water train tracks from Spirited Away, and the result was we got images like this, which are actually pretty nice, in my opinion. Like there are some quite nice ones here. But the versions of these, without the embedding, just trained on the prompt, are also quite nice. I got my roommate to see if he could tell the difference, and he couldn't. So I tried training embedding on Kill 6 Billion Demons, the webcomic, which is very good. And it completely failed. One interesting thing is when I applied the embedding, I started getting these comic panels. But if you look at the images that I actually trained on, none of these include any comic panels. So I suppose what happened is the embedding ended up finding its way into like a webcomic kind of a space based on these. It was like, yep, this is a webcomic. Okay, I'm going to embed myself as a webcomic. And as a consequence, we got this webcomic type feel. I tried a Zdzisław-Beksinski embedding, that didn't work. I also tried a hand embedding, trained on these images of hands to maybe tell the machine to make good hands. It did not succeed. I made this experiment where I just trained it on a bunch of yellow color swatches in the hope that it would learn that it's supposed to make the image look yellow. Instead, what would happen is the image, which, it was like an image of a road, what would happen is it would start off just being gray and weird, and slowly it would get more and more vertical lines in it as you increase the strength, and eventually you got to some yellow. But it mainly just learned the vertical lines. Okay, final one, my favorite experiment that I did, is I tried to make a John Ken embedding, who he draws monsters on these sticky notes. I could talk about this guy for a lot because I love his stuff. And I was like, wouldn't it be great if we could make an image look like this style? So I was like, train a monster in a forest. And that's what we got, this monster. What I was hoping for when I applied the John Ken embedding was for it to look like a piece of paper with lines on it. I wanted the artist's style. What I got instead was this guy. If you compare these two, this one looks a lot more John Ken. I suppose firstly because the washed out colors, but mainly because this guy's kind of cutesy, right? Like this monster here, it looks a little bit menacing, although not super menacing. But this one here, it really has a lot of character and it's sort of staring in the way that John Ken monsters often sort of stare and seem a bit apprehensive. So we didn't actually end up getting the physical, like, painting style of the artist, but instead we got some of the feel of his work, which is interesting because I would have thought that would have been way too subtle to pick up, but the embedding apparently managed to pick it up. Okay, so we're done. Any link to anything at all, it's in the description. Tomorrow, or maybe in like 6 hours or something, I'm gonna do a video on how this works under the hood, how aesthetic embeddings actually function. So that's going to be good. And if you have any questions before then or after then, you can reach me, Discord, YouTube comments, or maybe just read the YouTube comments because usually people answer questions in there. Okay, so that's it. Thank you for staying with me on this long ass tutorial.